the topic for this video is from chapter 4.6, adding and subtracting rational numbers. Like 4.5 on multiplying and dividing, this is a very broad topic. I'm going to try to do it in one video. We may have to take 2 days when we do the lesson. The big idea is that you can multiply and divide things that are different. So we didn't have to have a common denominator or worry about lining up decimal places when we did multiplication and division. But when you add and subtract, you have to be adding things that are the same. So you have to add ones to ones and tens to tens and hundredths to hundredths. So with decimal addition subtraction, you have to line up the decimal points. As it applies to fractions, the things that have to be the same is the thing that has to be the same as the denominator. So if you have 3/8 plus 2/8, you can make that 3 plus 2 over 8, just keep the same denominator, and add the 3 and 2 and get 5/8. But when you do 1/4 plus 2/5, these denominators are not the same, so you have to make them be the same. You do something with them, and that's where your idea of multiples comes in. It's from chapter 4.3. We have to know how to find a common multiple for 4 and 5, and then convert this fraction to something over that common multiple, and 2/5 to something over that common multiple. And one of the strategies for finding common multiples is to do count bys. Pick the largest of the two numbers, which would be 5, and count by 5s until you find something that's a multiple of 4. So we would try 5 first, and you can't multiply by 4 by a whole number and get 5. Then you try 5 times 2 is 10. That doesn't work. 4 times 2 is 8. 4 times 3 is 12. 5 times 3 is 15. That's not going to work. 5 times 4, well, you know that's going to work because it's these two numbers together. And that will always give you a common multiple. The advantage of getting the least common multiple is that your fraction, your answer will be in lowest terms when you get done with it. So we're going to use 5 times 4 gives us 20. And we are going to use the equal fractions property. We multiply the numerator and denominator by the same number. Basically, this is 4 over 4, which is 1. So we're multiplying 2/5 times 1, but it's a different form of 1. So we're going to get 2/5 in a different form. 2/5 is the same value as 8/20. 1/4 has the same value as 5/20. So now we follow our rule. When we have a common denominator, we add the numerators and get 13 over 20, which, as predicted, is out to be lowest terms. So that's what we were looking for. Pardon me a second. And what about positive and negative? This is going to be another thing we probably better review. It's not the same rule as multiplication, where if the signs are the same, it's always positive. If the signs are both positive, the answer will be positive. If the signs of the numbers you're adding are both negative, then the answer will be negative. So that's a different rule than multiplication. If one is positive and one is negative, it kind of depends on how these compare, and we'll talk about that in a second. And then if it's 3 plus -5, you would get -2. I'll just remind you of the method that we used in 6th grade to learn why this works. We use counters. Like this would be represented as 3 positives, 1, 2, 3, added to 5 negatives. A positive 1 and a negative 1, we call it a zero pair that adds up to 0. A number and its opposite add up to 0. That's a 0, that's a 0, that's a 0, and the net is -2. And then we learned that when the signs are different, you can find the difference between the absolute value of the numbers. The absolute value of how far is 5 from 0, it's positive 5. 5 minus 3 is 2. And then you give it the sign of the number that is farthest from 0. It's -2. So to make a problem that you would never use counters for unless you were really bored, if you have -117 plus 502, you would say, okay, I'm taking the absolute value of both of these numbers, the signs are different. Find out how far apart those absolute values are. 385 apart. and I'm going to make it positive 385 because there's more positives than there are negatives. There's 117 negatives and 502 positives. If I flipped these signs and made this a negative number, then that would be negative 385. So that's a quick review of adding positive and negative numbers. And of course, you're going to have to apply that to fractions and decimal numbers as well. It's an easy example to show you with integers, but you'll have to make that generalization to apply it to decimal numbers and to fractions. What about subtracting or adding decimal numbers? We had the problem of 6.1 minus 6 1/10 minus 4 2/100. I'm going to rewrite this in vertical form, being careful to line up the decimal points because that lines up place values and it follows the principle that you can only add or subtract things that are the same. This is the ones column. We can't remember to subtract tenths from the ones column. So ones and ones line up, tenths line up to tenths, and hundredths to hundredths. And here we have 0 hundredths. It would be a mistake to just say 2, 1, 2. Because there are 0 hundredths, and we're going to have to go 10 minus 2. 0 minus 0, and 6 minus 4. It's always, when you're adding, it doesn't matter if you don't annex those zeros. You can just bring the numbers down. If it would have been an addition problem, the answer would have come out the same whether I put that 0 there or not. But it's just a good idea. Because with subtraction, sometimes it does make a difference. Good idea to put it there every time. So what if I had, let's try, we'll make a more complicated problem. Negative 5 1/3 minus, let me go with subtraction, so we haven't done that yet. Subtracting integers. Okay, I learned from another teacher a really cool memory device, and it was the KCC principle, which stands for keep, change, change. The algebraic definition of subtraction says when you're subtracting integers, you can, if you want to, make it A plus the opposite of B. And that will be helpful here. You keep this the same, K for keep, change subtraction to addition, and change the sign of the number that you were subtracting. So you keep this, negative 5, change this to addition, and change this sign. If it's negative, make it positive, and if it's positive, make it negative. It's negative, so I'm going to make it positive. And you can just, I could easily have done it just like this. But I wanted to kind of see what the original problem was. So now we have 5 negatives and 3 positives. We have 2 more negatives than positives, so that would be negative 2. So you can always convert a subtraction problem to an addition problem, just as in the previous section we changed division to multiplication. So what if we have something like a denominator of x, and we have 3 and 7. 3x plus 7x. Well, these are the same denominators, so we can keep that. It's just like it's 3 tenths plus 7 tenths. It would be 3 plus 7 over 10. It's 3 plus 7, which is 10 over x. If it's 3a plus 7a, it's 10a. If it's 3a plus 7b, we can't just add the 3 and the 7. Can you figure out why we can't do that? They're not the same. The same in algebra is defined as the same variable to the same power. That's an a and that's a b, that's not the same variable. We can represent it. It's 3a plus 7b. So that's how you would answer a problem like that. I think in the work in this lesson, as far as the algebra goes, we're going to be working with denominators that are always the same, so it's not going to be, it's not quite as complicated as it might get a little bit later on. So if we have, let me take a comment out of the book here. It looks 3x over y. Okay. I like this problem because this can be confusing sometimes because you're looking at what am I subtracting here from 3x? They have a common denominator, so that doesn't need to change. But we're trying to do 3x minus an x. So if you have 3 x's here and you take away one of them, how many are left? 3 take away 1 would give us 2. That's 2 of x, whatever value x has. So this would be 2x over y. And that's a quick overview of adding and subtracting rational numbers.